All right, there's a lot we could get into with this concept, but because of how weird this year is, we're just going to keep this as simple as possible. So this is L'Hopital's rule, and L'Hopital's rule has to do with how we're going to calculate limits. And specifically, it's going to apply, and again, we're just going to focus on these two cases this year. If we try to plug in our limit and we get a value of 0 over 0, or we get a value of infinity or infinity over infinity, then L'Hopital's rule is going to come into play. So both of these are undefined values. We've dealt with both of them in pre-calc and at the start of this year. And so if we try to plug in a limit and we get this value, then there has to be a method for finding what the limit should actually be to avoid this error, this undefined output. So for example, if we were to do something like the limit as x approaches 2 of x squared minus 4 over x minus 2, well, if we plug in 2, we're going to get 2 squared minus 4, which is 4 minus 4 over 2 minus 2, which equals 0 over 0. And that's our undefined value. So L'Hopital's rule is going to allow us to calculate this limit and figure out what the value should be. So the basic idea of L'Hopital's rule is that when you plug in your value and you get an output that is undefined, like 0 over 0 over infinity, then you can take the derivative of the numerator and the denominator of your fraction and apply your limit again and see if it works that time. So in the case of this first example, if we do the derivative of the numerator, then we get 2x minus 0 over the derivative of the denominator is 1 minus 0. So now we can try to apply our limit again. Limit as x approaches 2. And now when we plug in 2, we don't get 0 over 0 anymore, but rather we get 4 over 1, which is equal to 4. So we can say that this limit is equal to 4 because we applied L'Hopital's rule to figure out what it was when we ran into our 0 over 0 issue. So the limit as x approaches 2 is x squared minus 4 over x minus 2 is equal to 4, and we determine that by applying L'Hopital's rule. So in this case, if we plug in 4, we're going to get 0 over 0. We get 16 minus 16 over 2 minus 2. So if we do the limit as x approaches 4 of the derivative of the numerator, which is going to be 2x minus 0, divided by the derivative of the denominator is going to be 1 divided by 2 root x minus 0. Now we can just try to plug in 4, so we get 2 times 4 over 1 over 2 times square root 4, which is going to be 8 over 1 over, 2 times 2 is going to be 4. So now we just need to simplify this. So when we're dividing a fraction like this, we can multiply by the reciprocal. So we're going to do 8 times 4 over 1, which is just equal to 32. So this limit is equal to 32, which we determined by applying L'Hopital's rule. Okay, let's try it with this one. Limit as x approaches 5 is going to give us 25 minus 25 over 5 minus 5. So L'Hopital's rule comes into play. We're going to do the limit as x approaches 5 of the derivative of the numerator is 2x minus 0 over the derivative of the denominator is 1 minus 0. So then if we plug in 5, we get 2 times 5 equals 10. I don't know if you remember doing a lot of these annoying limits in pre-calc, but we actually had to do a different method that took longer to calculate these. So now that we have L'Hopital's rule, these limits are much easier to calculate. So let's try this one. If I were to quote-unquote plug in infinity, I'm going to get 3 times infinity squared minus 4 over 7 times infinity squared minus 4, which is just going to be infinity over infinity, right? Impossible to calculate. So L'Hopital's rule is going to come into play here. So we can now do the limit as x approaches infinity of, we'll do the derivative of the numerator is 6x, the derivative of the denominator is 14x. Okay, if we try to plug in infinity again, we're just going to get 6 times infinity over 14 times infinity. So let's try it one more time. The limit as x approaches infinity of the derivative of 6x is 6. The derivative of 14x is 14. Okay, so our limit's just equal to 6 over 14, which is 3 over 7, right? So the thing with this is just the horizontal asymptote. So our horizontal asymptote rules are still in play here. As we approach infinity, we're going to approach a horizontal asymptote if there is one. And since this is a degree 2 over a degree 2, we know that our HA is just going to be at 3/7 from those horizontal asymptote rules we learned in pre-calc. And L'Hopital's rule just further justifies that by taking the derivative until we can take a limit that will give us a real output. And we see, oh yeah, it's 3/7 just like we expected, right? So if we do, I have one more to do, but I want to do another horizontal asymptote one really quick before we do this one. Okay, so let's say we have something like the limit as x approaches infinity of 2x squared minus 5x over 5x cubed plus 2. Okay, we know by our horizontal asymptote rules that this should be equal to 0, which is totally okay to just determine that by looking at our horizontal asymptote rules. But if those rules are still kind of confusing for you, L'Hopital's rule comes into play here too. So we can just take the derivative of the numerator and the denominator until we get what we want. So the derivative of 2x squared is 4x, minus the derivative of 5x is 5, over 15x squared plus 0. Okay, if we plug in infinity, we're still going to get infinity over infinity. So let's try again. Limit as x approaches infinity. The derivative of 4x minus 5 is just going to be 4 over 30x. So now if we plug in infinity, well, we're going to get 4 over 30 times infinity, which is just like 4 divided by infinity, which is just going to be 0, just like we expected from these from our horizontal asymptote rules. Okay. So last one, if we plug in 0 here, we're going to get e to the 0 minus 1 over 0 squared. Okay. E to the 0 is just 1, so we're going to get 1 minus 1 over 0, which is, oh no, 0 over 0. So you guessed it, L'Hopital's rule comes into play. Limit as x approaches 0. Okay. So the derivative of e to the x is just e to the x, minus the derivative of x is just 1. Okay, the derivative of x squared is 2x. Okay, if we try to plug in 0, again, we're going to get e to the 0 minus 1 over 2 times 0, which is 1 minus 1 over 0, which is still 0 over 0. So L'Hopital's rule is going to kick in again. So now we're going to do the limit as x approaches 0 of e to the x. Okay, the derivative of 1 is just 0 over 2. And now this is going to work out nicely. We have e to the 0 over 2, which is just 1/2. So this original limit is just equal to 1/2, but we couldn't figure that out at first because when we tried to plug in 0, we kept getting an undefined value. So we take L'Hopital's rule until we can plug in 0 and get a real value, which is what we got here.